Okay, in this video, I'm going to explain how to develop a pulse generating program in TIA portal. Here I have created the new project in TIA portal. For this tutorial, I'm going to use the CPU 1215 C-type PLC. These are the PLC we are going to use for this tutorial. Okay, to generate the pulse, we are going to use the single timer, on delay timer. Okay, this is the program we are going to use to generate the pulse. The self resetting on delay timer is we are going to use to generate the pulses. Okay, let's see how this program is work. First, here you can see in this first network, you can see the on delay timer, 10-second on delay timer. The input signal is given by M0.0. Here is a normal close. At initially, there's a power flow to the on delay timer. So the timer at initially timer start its timer counting. When the timer counts is greater than or equal to 4 seconds, you can see this is the comparator operator. You can see the upper value and the lower value. If the upper value, that means this upper value means the timer elapsed time is greater than or equal to 4 seconds, it gives output from the Q 0.0. Then when the timer reaches to the 10 second, when the timer get overflow, you can see when the timer bit is set, so then M0.0 set. So what happened? At that scan cycle, this M0.0 goes high, so timer elapsed time. When the power flow disconnected, timer elapsed time and also the timer output goes to low. So when it goes to low from the next cycle, this bit also goes to low. From the next cycle, power flow again continue to timer on delay timer. Okay, this is how self resetting on delay timer is work. You can clearly understand through this timing diagram. You can see the timer current value how it is vary. M0.0. Here you can see at initially it is a state low state. So because this is a normally closed, there's a power flow to the timer, so the timer start is timer counting. So when the timer reaches to the 4 second, you can see the Q0.0 goes high because comparator, so greater than or equal to 4 seconds. So it retained for 6 seconds. Here you can see it retained for 6 seconds, then it goes slow because timer reset when because of the M0.0 goes high, because the timer when the timer get overflow, timer bit is set, so there's a power flow to the M0.0. So for one scan cycle, the M0.0 goes high, so the timer reset, time elapsed time goes to 0, and also the timer bit also goes to 0. So then again timer from the next cycle, again the timer start is timer counting. So then you can see that after 4 seconds it gives output from the Q0.0. This is how self resetting on delay timer is used to generate the pulses. You can adjust any value. If you want to get the 5 second and 5 second, by putting the required value in here, you can get the required pulse width for the pulse output. Okay, let's develop this program and run, and let's try to obtain this timing diagram using the signal tracing method. Okay, let's go to the TIA portal. Okay, here I'm going to open the main program block. Okay, first of all, I'm going to insert the timer. On delay timer we are going to use. Initially, it asks to create the instant data block, so I'm going to give the T1 for the name for the data block. Click OK. Okay, here the preset time. So for the preset time, I'm going to put 10 second. So type the 10 and letter S, enter. So input signal I'm going to give using a normally close contact M0.0. Let's take the memory bit, so then we can easily switch M0.0. Let's rename this tag as start signal. Start change. Okay. Then next we are going to insert the comparator. Here all the comparator operations are listed under the comparator operations. You can see once you click in here, it expand. You can see the different type of comparators. So you can compare data using these comparative operations. Thing is, if you are you can compare only same data types. That is very important. So I'm going to use this greater than or equal comparator. So I'm going to drag and drop it here. Okay, for the upper value we have to give the timer current value. That means the timer elapsed time we have to give. So let me give this value. Click here and go to the timer, the instant data block. So click here and elapsed time, select the elapsed time, enter. So automatically the comparator change its data type as time. The next we are going to give as the 4 second. Here you can see the any value you can give according to the uh, pulse width you want. Here I'm going to use the 4 second. The click here and type the 4 and type is enter. 4 second. Okay, once this condition is satisfied, we want to give output from the output port. Let's take you're going to give this output from the physically available port of the PLC. Here the physically available port, all the ports are listed in here under the input output tags. Under the PLC you can see that all the input outputs are listed in here. So you can simply drag and drop this address to here. Okay, let's rename this tag as or something. Let's take the bulb. Yeah, click OK. Okay, then you can see when the time elapsed time is greater than 4 seconds, there's a power flow to the bulb. So then next step, we want to reset the timer after 10 seconds. So when the timer get off flow, we want to reset. So that means we are going to switch on the M0.0. So okay, M0.0 in here, enter. So then for this normally open contact, I'm going to select the timer output bit, enter. Okay, now the program has completed. Program has completed. Okay, here you can see the program, develop program. Now we are going to simulate this program. So first of all, let's compile the program. Okay, let's compile the program. You can see the zero errors and zero warning. Okay, let's simulate the program. Start simulation. It will open PLC sim software. Well, now it's okay. Okay, okay, now it's okay, connected. Okay, so then I'm going to load the configured data. So the connect, okay, load. So then I'm going to turn on the start module, finish. Okay, let's run the program and see how it works. So click here the monitoring on off. Okay, without any trigger signal, it should open because there's a normally close contact to the timers because the timer counting is starting. You can see the how Q0.0. Now you can see it is it's set. So yeah, there's a switch off. You can see. So then again you can see the comparator time value here. You can see if it is greater than the 4 second, you can see there's a power flow to the bulb. So then it is disconnected. You can see 1 second, 2 second, 3 second, 4 second. At the 4 second, there's a power flow develop. At the 10 second, that is there should be shoot off. Yeah, you can see. Okay, this is how we are generated the pulse output using the single time operation. So okay, next we are going to obtain this timing diagram using the signal tracing method. So then you will get a more clear idea how this program is work. Okay, here I'm going to use tracers. Go to the tracers, the double click, add new tracers. The first of all, you have to define what are the signals you are going to trace. The signals, click here, click here. Okay, first of all, I'm going to monitor timer current value. Okay, select timer current value. So here I'm going to select it from the timer instant data block, so the timer current value, so enter. So then I'm going to trace the output, and also I'm going to trace start signal to the timer. Okay, these are the three signals we are going to trace. Then you have to define what are the sampling method you are going to use. So here as the default, the one in here, they record every one cycle after the main program execution of a main program. So that much of accuracy we don't want. So I'm going to set it as the 100. And also I'm going to put the maximum record duration as the maximum. Okay, that's all. So here I'm not going to give any trigger signal to start the monitoring. So I'm going to keep it as it is. So I'm not going to give any measurement on devices. Okay, that's all. Okay, let's transfer this configured data to the PLC. Okay, yes. Now it's okay. You can see the three colors for the three different signals. You can see the output, the blue color, the start signal is green, and also the time elapsed time is pink color. Okay, let's start the monitoring. Activate recording. Here you can see. Okay, then let's open the main program as well. Let's go to the main program. Click here the start. Then you can see the both program and the timing diagram. Here you can see timer current value reaches to the 4 second. It gives output to the bulb. Okay, you can see the pulse generated pulse pattern. You can change the pulse width according to your requirement by giving this comparator this value. So let me show that one also. Okay, before going to that one, you can see there's a no variation for the M0.0. The reason is our accuracy we have set to the 100 cycles. That means every 100 cycles we are going to record this data. So this M0.0 switch on for one scan cycle, so that's why that is not shown in here. That variation is not shown in here, M0.0, because it's switch on for only one cycle. Okay, let me change this the value, then let's see what happened. Okay, let's go to the offline. Let me change this value for the 6 second, then let's see what happened. Then yeah, compile, then transfer data, load. Okay, then let's start monitoring. Okay, let's see how this program is work. Okay, now you can see the pulse width in here. You can see once we change this comparator low value to 6 second, you can see timer, when the timer elapsed time is greater than or equal to 6 second, then it will passes the power flow to the Q0.0. Here you can see the pulse width has changed only for 4 second Q0.0 in high state. Okay, this is how you are getting required pulse output. I think you all got a clear idea how to generate the pulse output using the self resetting on delay timer in TIA portal. Okay, thank you. See you on next tutorial.